Okay, so we have to discuss a few homework questions. Let's get started. Can you see my whiteboard?
Yes, I can.
Okay. So what were the questions? Let's talk about question for first. So the question was you had to integrate from 0 to pi by 8 and the function was sine 2x cos 2x dx. Now, on the basis of the methods we have discussed so far, we'll be solving according to that, right? So, in my example, I told you, I'll give you a quick background. So, we have been using this logic that if you have been asked to integrate a function, you need to think of that function as a derivative, right? And you have to think that which function's derivative is this. So f dash x is derivative of f of x plus c, right? This is the underlying logic. You understand this?
Yes.
Okay. So we know this. So on the basis of this formula, what is my f dash x? In my example, in this example,
Negative cos 2x.
sorry,
Negative cos 2x.
no, Ranjani, the part inside the integral is f dash x, right? This is not f of x. You are not differentiating this. This is an integration question, and you have to solve this integration by this method. Okay. So, according to this method, the function which comes inside the integral, if this is my integral, the function, this function is considered to be the derivative function, right? So now tell me which is the derivative function in my case. This is my integral. This is the function. So my f dash x could be sine 2x cos 2x, right?
Yes.
Do you understand this? Why?
Yes, I do.
Okay. Because look, the underlying logic is that you have an integral sign, then you have a function, right? And that function is considered to be basically a derivative of some other function. And you need to think of that other function in order to find this integral. This was the logic in this unit on this section, right? So this is my f dash x. I have my f dash x. I need to think of my f of x. So this is a derivative. We need to think of the function whose derivative is sine 2x cos 2x. So what would be the function? We cannot tell anything directly. We need to make guess. Okay. So the initial guess would be that let's say this function is sine 2x whole square, right? What if this is my initial guess? And what if now I find the f dash? What would I get? Tell me, please. What would be my f dash in this case? If I'm saying my initial guess is sine 2x whole square. So yeah, now tell me the derivative of the sine 2x whole square.
Cos 2x.
No, Ranjani, we have a square here, so we need to do it.
2 cos 2x times 2.
And what about the sine? Look, this 2 would come here. The sine 2x function would come as it is. Remember, we have discussed this. And the derivative of sine would come here, okay? Cos 2x. And then we need to write down the 2. Yeah, very good. Okay. So this is what we would get if this was our f of x, okay? If this was our f of x, we would have differentiated it, and this would have been our derivative. But in our example, this is the derivative. So how can I change this derivative to this derivative? What should I multiply or divide with this f of x in order to get this instead of the function I'm already getting? Hmm? If I divide 4,
Divided by 4.
excellent, right? So now you know that the integral would be sine 2x whole square by 4 pi by 8 to 0, right? And this is basically a definite integral. Okay. Now you simply have to insert values, okay? So how would you do that? Sine 2 at pi by 8 square by 4 minus the other one would be sine 2 at 0 square by 4. So this would be 1 by 8 and this would be 0. So the answer is
1 by
1
8.
by 8. Okay, so you need to understand this, that here this part which is written inside the integral function is considered to be the derivative. This is the f dash of x. We need to think of this function as the derivative of some other function. And you need to think of that other function whose derivative is this. Although you have been asked to integrate it, but the logic says that think of this integral as if you are integrating a derivative. If you have sine 2x cos 2x, you need to think of a function whose derivative is sine 2x cos 2x. Do you get it?
Yes.
Are you sure?
Yes. Before initial guess, why did we square sine 2x?
Okay, because look, we know that if we will have sine 2x square, only then I would get this sine 2x as well. If I had cos 2x only, my derivative would have been cos 2x into 2, right? In what we have the sine 2x in my derivative function. I have the sine 2x in my integral. So I know that whatever function I will choose as my initial guess should be such that if I differentiate it, I at least get sine 2x and cos 2x, and we will play with the constants like we
Yeah,
divided 4,
I got it.
right?
Yes.
Okay, perfect. So let's do the eighth question now. Now, this eighth question is very easy. Why? Because it is a straightforward formula. You don't need to do a method or something of that sort. It is a direct formula which you should know. Cosecant square 3x plus 2 dx. Okay. So let me change the color. Solution. Okay. Now you need to know one thing. Yeah. Sorry. You should know that the integral of cosec square x
It's 1 by sine square.
uh, dx. Yeah, the integral of cosec square x, I've missed the x, is not 1 by sine square x. It is minus cot x. We have discussed this in our last class, in Sunday's class. We talked about this, right? Okay, it's okay. It is a complicated function. It just has you just need to memorize it, nothing else. Okay. So this is what we know when we have cosec square x, right? This is the integral in case of cosec square x. Now there's a difference in our example. How would we play with the difference? So when we have cos x square x, we have cot x. So this would be minus cot. Now we don't have x, we have 3x plus 2. And the derivative of this function, what is the derivative of this function?
3.
Very good. So we need to divide the derivative of this function. And this is the answer, right?
Yes.
Is it clear?
Yes, it is.
Okay. Right. And let's talk about another question. Although it was correct, but there was just one part which had an error. Let's discuss that. Sine. And both these questions had similar errors, so I'll just do one, okay? Dx, okay. Now, I would definitely appreciate that you attempted it correctly, as in you started off correctly. Now we know that we need to think of it as a derivative function, and we know that sine square is not a derivative. Okay, we don't have any function. There's no function whose derivative would be sine square x. So since this is the case, we need to change sine square 0.5x to 1 minus cos. Now here was a mistake, x by 2 dx. I'll tell you. Basically, we know that sine square x is 1 minus cos 2x. Okay, so you had a mistake with in this two part, right? Rest was correct. Do you understand now?
Yeah.
I mean,
Yes,
yeah,
I do.
I'm doing it, but just understand the difference in your solution and in my solution. Okay, right. So this is what we have now. We need to integrate it further. We can break down this integral like this. And this would be 1 by 2x minus sine x by 2 plus c. Because the integral of cos is sine. Okay, the integral of cos is sine. It's not minus sine. This 2 would come as it is. And the integral of 1 by 2 is x. So is it clear?
Yes.
Right. Are you sure? Because then we'll be moving on to our new topic, that is 5.4. So just
Okay,
ask
yes.
me. It's clear,
It's
right?
fine.
Okay, very good. Okay. So it is the 5.4 section of your book. Integrating one over x square plus a square. Right. So this is the topic. Now you need to think of a function, let's say f of x. If f of x is tan inverse x, now this is basically your previous knowledge. We have already discussed the differentiation chapter. So my question is, what would be the derivative of this function? If,
X square.
sorry,
No. X square. No,
it's okay, you can try, just guess. Okay, so we have 1 over 1 plus x square. So we
yeah,
have
1 over
1
1 plus
over
X
1
square.
plus, and then the function over here comes here as a square, right? With a square. Do you
Yes.
understand this differentiation?
Yes.
Okay. So now you have these two things, and now I want a correct answer. Okay. I mean, it's okay if you are not being able to, but still. Now, what if I ask you, what if I tell you that we have been discussing this that the integral of a derivative is equal to the function whose derivative is f dash x. You know this, right?
Yes.
So now my question is that what if you have 1 over 1 plus x square and you need to integrate it? So what would be its integral? Take your time. You have
Tan
everything.
inverse of x.
Excellent. Very well done. Very well done. This is the whole concept behind this unit. You only need to know these things and you are good to go. Okay. So yeah, I will do everything on this page because this is the most important page, and then we'll be practicing questions and you will be done with this unit. Okay. So you have told me that the integral of 1 over 1 plus x square is tan inverse x. Excellent. Now look, if we have 1 plus x squared, things are very like things are not general, right? We need to know a general formula. Here we have 1 and 1. What if I ask you to consider, now can think of f of x as 1 by a tan inverse x by a, and a is a constant, right? Just know that. You should know the difference in a and x. What is the difference in a and x? X is a
A is
variable,
yeah.
yeah, and a is a
A
constant,
is a
right?
constant.
Very good. So a could be any number like 1, 2, 3, 4, 5, 600,000, any number, but x is a variable. So your operations with a and x would be different, right? Very good. Okay. This is f of x. Now you have to tell me the derivative of f dash x. When f of x was tan inverse x, the derivative was this. Now we have a similar function. The only difference is we have an a here. So what would be the derivative, Anjali? Take your time and tell me, right? Take your time. Look, this a is a constant. So 1 by a would be a simple number and my derivative would not be affected by that, right? Do you agree? So I will write down this 1 by a as this. Right. Now we need to focus on this part only, tan inverse x by a. So when we had tan inverse x, my derivative was 1 over 1 plus x square. So we have discussed in differentiation that the derivative of tan inverse function comes like 1 over 1 plus x by a square. Agreed?
Yes.
And what is missing? We need to write something over here. The derivative of this function.
Yes.
So that is 1 by a.
A.
So this would be 1 by a square, and this would be 1 over a square plus x square by a square. How did I do this? Basically, I've opened this thing into x square by a square, right? I will get x square by a square and then I'll take LCM. Okay, so this is how I got this. This is a square, and then finally I will get this a square would go here. So I have a square and I already had this a square. This would be a square plus x square. So it would be 1 over a square plus x square. Do you understand the differentiation?
I do.
Okay. So if you understand the differentiation, just like you answered earlier, what if I ask you, tell me the integral of this function? So what would be your answer? Everything is on board of this function.
It will be 1 by a tan inverse of x by a.
Very well done. 1 by a tan inverse of x by a plus c. Okay, excellent. So again, we are using the same concept, but Now things would be very, very direct, okay? Now, whenever you come across a question of this type, we will discuss the examples where the expression looks like 1 over a square plus x square. Your integral would be of this form. So all you need to do is you need to be observant. You need to see. You need to identify the type of question. Now this is the first type, right? Where when you are coming across 1 over a square plus x square, obviously in your question you will not have a square. You might have 25. So if you have 25, your a square would be like, if 25 equals to a square, you will have 5 square, right? This is how you need to convert things and finally use this formula. So is everything clear? Should we discuss the example?
Okay, yes.
No, tell me if something is not clear.
No, it's clear.
Okay, I will clear the slide and I'll tell you the basic learning of this. Okay, so the learning outcome is the thing that you should know, the thing which you should have on your fingertips is that whenever you come across a question of this type, 1 over a square plus x square. Now, this depends upon your observation. Okay, the question would not be this straightforward. You need to make it look like this. Your integration or your integral or your answer would be tan inverse x by a plus c. Right? Agreed? Do you agree?
Yes.
Okay. So this is what you should know. Okay, and I would advise you to write this again on this formula on your on your A4 paper and paste it somewhere, just so you learn all the formulas quickly, because we will have another test on Friday for your learning, obviously. Okay, so the question, and yes, I agree that in like the Cambridge system is good enough that they provide you with formulas and everything, but trust me, never ever rely on those formulas. Okay, before applying the formulas, you should know how to apply them, and for the replication, you should know that, okay, if I have an integral of this type, the one I'm writing, how you would be applying the formula. That is more important than just using the formulas directly. Okay, now you have this question and you need to find the integral. Okay, so how would you attempt this question? Any idea?
ln of 4x square plus 1.
Sorry, say it again.
ln.
Okay, okay, it's okay.
ln of 4x square plus 1.
Okay, so you are saying that the integral would be ln of 4x square plus 1, right?
Plus 1 times
Okay,
um 8x.
8x.
Yeah.
Okay, right. Now listen to me. How did you guess this integral? Again,
Because
again, I would
um
appreciate that, yes, you were close, but the thing is that this would have been your integral if you had the derivative over here. The derivative of this function is 8x, right? So you did not have this 8x here. So, like, if you think of this, if you think of this as the f dash of x function directly, let's do it that way first. If you think of it as the derivative function, your f of x, this is what you said, right? Your f of x cannot be this. Why? Because if this was your f of x, the derivative would have been 1 over 4x square plus 1 into 8x. The derivative of this function comes in the
you have
numerator.
to divide it by 8x.
No, exactly. Okay, very well done, very well done. But the thing is that you can divide 8, you can divide 10, you can divide 1000, but you cannot divide 8x, right? You cannot modify a function this way. I mean, this is what you are saying, that you can take 8x here and you can take 8x here, right? This is what you are saying.
Yes.
Now look, Ranjini, obviously I cannot take 8x in the numerator only, right? I would have to take the same number in the denominator as well in order to neutralize them. And I cannot have this 8x outside this integral because of this x. So it would be, this function would become something of this type, 8x over 8x into 4x square plus 1, right? This is what I would get if I add this 8x and I would be dividing it as well. So if I will be integrating this, this is again, the integral again would not be ln. In fact, things have become even more complicated in the denominator. Yes, you could have done this if you had x, if you already had x in the numerator. You can always multiply and divide a number. You can always multiply and divide 8 only. But since you had this x, you cannot say that, okay, I can multiply 8x in the numerator and I can divide it in the denominator because of this x, right? When we are basically multiplying and dividing things of our choice, those things are constants only. They do not include a variable. Why they do not include a variable? Because then I would have to include this inside the integral. Is it clear? Like
Yes.
I have 4x square plus 1 dx, and I agree that if I had an 8x in the numerator, I'll write the wrong things with this. I would have calculated this integral by the ln method. I agree. But if I need something in numerator, I need it in denominator as well. And in this case, I cannot say that my 8x would come here because I have this x. In the previous cases, we simply multiply the reciprocal of this number outside. But here, this isn't a constant. Here we have a variable with it. Okay, so just remember, when you are dealing with integration, and you just write down this note in your diary or in your notebook, that when you are dealing with integrals and you have been asked to modify your function, you cannot modify your function by multiplying or dividing a variable.
Okay.
If you had this as your question, then definitely you could have
We could
said
have
that,
taken yeah, x outside or something.
sorry.
We could have divided by 1 by 8x.
Yeah, 1 by 8, not 1 by 8x, because you had this 8 already, right? This is what I'm saying. If your question was of this type, if this is not the question I have written, this is the question I just made up to explain you. If this was your question, then yes, you could have said that I can multiply 8 and I can divide 8, and now the derivative of this function is in the numerator, and yes, you can apply the ln thing directly. But here you did not have this x. You did not have this x. Since you did not have this x, you cannot multiply 8x and divide 8x because of this x. Do you understand this now?
Yes.
So what have you understood? That
That you cannot divide any variable.
very good. Why? And what is the, and you cannot even multiply it. What is the logic? Do you understand the logic as well?
Completely.
Sorry?
Not completely. I
Okay.
don't.
Okay. It's completely okay. Okay. Now look, I'm saying if the question was of this type, x over 4x square plus 1 dx, right? In this case, you could have said that my integral would be of this form. Why? Because you need the derivative of this function in the numerator. What is the derivative of this function? 4x square.
8x.
Very good. So the only missing thing is 8. You can always write this 8 and you need to divide it as well, right? So yes, you can do
So
this
you
in
can
this way.
cancel it.
Yeah, exactly. But you would not cancel it, no, because this is what you had to have. This is what you were supposed to have in order to do this integral by using the natural log logic. This is what your supposition was,
Yes.
right? What is the natural log? When can you use this natural log thing? Whenever you have a derivative, and this is the next section. This is the next section. We will talk about this in a minute. Let's not talk about this right now. This is the next section. Let's just do this integral. And you know one thing that we have already talked about this. So when we have discussed this, and when my question was of this type, the integral in the second question would be of similar type. Now tell me the integral. We have already discussed this, right? We have discussed this.
Yes.
And this is the first question. Now you need to make things look alike. You have x square here and you have 4x square here. So you need x square here only. So you will take 4 common. So if you, and obviously you cannot take 4 common, you will take 1 by 4 common, right? This is basic maths. So you will get 1 over x square plus 1 by 4, and now you have x square. You are done with this part, but you need a square, and this is 1 by 4. So you basically need to think of the under root of this number. So this would
1
be
by 2.
1 by 4 integration 1 over x square plus 1 by 2, that is 0.5 square dx. Now things look alike, right? We have 1 over a square plus x square. We have 1 over a square plus x square. My a square is, what is my a square? 0.5 square. So I need to
Yeah.
apply this formula directly. 1 by a would be 1 by 0.5 tan inverse x by 0.5 plus c would be the answer. The only thing you need to know in this case is that whenever you have question of this type, 1 over a square plus x square. Now look, the type wasn't directly this. You need to make it look like this type, right? And how did you do that? You need to have x square in the denominator. Here you had 4x square. So you need to take 1 over 4 common. And then you had 1 by 4. But you have a square here. So you need to find the under root of this function and then write it down with square. Okay? And once things are like this expression, you can simply use this formula directly. Do you get it?
Yes.
Very good. Okay, let's talk about another example. Okay. So second example, you need to integrate 2 by 3x square plus 4 dx. Now again, I will give you a hint and you have to solve this. The hint is that 1 over x square plus a square dx. The integral of this function is, tell me what is the integral, Ranjani? 1 by A.
1 by A tan inverse
Very good, excellent. X by A plus C. Okay.
plus C.
Now
Yeah.
you have to help me in this question too. So I have told you that you will be using things like this, but you need to make this integral look like this one. This is the only challenge in this case, okay? So let's start off with the numerator. You have 1 here and you have 2 here. So you will take 2 outside and you will be left with 1 over 3x square plus 4 dx. What would be my step 2? Now you have to tell me this x square is alone and I have 3x square here. So like the previous example, I will take 1 by 3
1
outside.
by 3. Yeah.
Excellent. So this would be 1 over x square plus 4 by 3, right? Why 4 by 3? Because when I will multiply this 3 with this 4 by 3, I would get 4. Okay?
Can you repeat that?
Yeah, sure, sure.
Oh, yeah, I got it. When you multiply, you will get
4.
4.
Very good, right? Dx. And what is the last modification we need to do in order to make it look like the general formula?
You have to take the under root of
Yes, very well done. Of what?
4 by 3. 4
This
by
would
3.
be 2 under root 3, right?
Yes.
Square dx. Now you can apply the formula directly. Now this 2 by 3 would come as it is. 2 by 3. There is no 2 by 3 or anything of this sort over here. So it would come as it is. Now you need to apply this formula directly. What is our A, Ranjini? What is our A?
2 by 3.
2 by under root 3, okay?
Yeah, sorry. 2 by under root. Yeah.
That is okay. So 1 by A would be under root 3 by 2
2. Yeah.
tan inverse x by 2 by under root 3 plus C. This is the answer. Do you get it?
Yes, I do.
Okay. Now when we will talk about the next section in a bit, you will know that you will understand the difference in the thing you had confusion with. Okay. Okay, let's talk about the last question. It is a word problem type thing. So the question says the equation of curve is y equals a by x square plus a square. Find the exact value of area bounded by curve the positive coordinate axis and the this. So this is the question. The equation of curve is y equals a by x square plus a square. Find the exact value of area bounded by the curve, the positive coordinate axis, and the line x equals a. Now, we have no idea how the curve would look like, okay? Let's say this is the curve. This is just a random guess, okay? You don't have to know the exact shape in this case. Obviously, you can always plot the curve, but you just have to understand the question. So they're saying find the exact value of area bounded by the curve. Okay, so one boundary would be curve, the positive coordinate axis. So this is the second boundary, the positive y-axis, and the positive x-axis and x equals a. You need to find this area. So cutting it short, you need to find area under curve,
From
right?
0 to A.
Excellent. So the whole thing is basically integrating a over x square plus a square from
0 to A.
very well done. And now tell me, how would you do this? You okay? What?
Take A outside.
Huh?
You take A outside the integral.
Excellent. Very well done. Yes. Very well done. And now you are left with the
1
general
by
form.
x squared plus A squared. Yeah. So you'll get 1 by A tan inverse of x by A plus C.
Excellent. So my integral would be, a would come as it is. Then I need to write 1 by a tan inverse x by a plus c. I need to cancel this out and I will have tan inverse x by a from a to 0. This would be tan inverse a by a minus tan inverse 0. So this would be pi by 4. Why? Because tan inverse 1 is pi by 4. Do you get it?
Yes.
Very good. Okay, so we are done with this section. Let's talk about the other one. Are you sure that you have understood everything clearly?
Yes.
Okay, right. So it is 5.5. Integrating expressions of the form f dash x over fx. Now this is the section which we will discuss. Now, Ranjini, they are saying that you have a fraction type of an integrand, right? This is the integrand. You need to integrate this, and the form is f dash x over f of x. Okay. So now here you can say that the integral would be ln f of x plus c, right?
Yes.
Because again you need to think of it as the derivative. Okay, let's say this is g dash x, and now you need to think of a function whose derivative would be of this type. So this would be the function. If you differentiate this g of x, you would get 1 over the bracket thingy would come here, and the derivative of bracket part would come there, right?
Yes.
So this is how the integral of this type of fraction would be this. You get it?
Yes.
Okay, so I'll clear this. And the learning and the main thing we need to focus at is, whenever you come across an integral of this type, where you have the derivative in the numerator of a function which is in the denominator, the answer would be natural log f of x plus c. Now, you would never be given such a straightforward form. Obviously, you would have to make some modifications in your question to make it look like this form. But once you are done with the modifications, this would be your integral. So this is the second form, and the first form today we have discussed was 1 over a square plus x square dx. Please write these down on a white paper, okay, after the class. Tan inverse x by a plus c. So you need to learn these two types should be on your fingertips, okay? You need to be quick enough to look at the question and know that okay, I will use this here, okay, I will use this here. Right. So let's just discuss it directly. Okay. Let's do an example. Example number 1. X square over x cube plus 1 dx. Now you need to integrate this fraction. Now you can think of the tan method first as well, but obviously you have x cube here and you have x square here, so it is very different compared to the general form, right? You apply the tan inverse thing when you have this type of an integrand, right? So you can see that you have x cube here, you have x square here. The forms are very different, so you cannot use the tan method, right? This is how you will understand the application of rules. So you are clear with
Why can't
my.
we use the tan method here?
Okay, I'll
We
tell
can
you.
take x square outside, right? Outside
Okay.
the integral.
Okay, but Ranjani, you can never take x outside the integral because this is being integrated with respect to
Oh, we
x.
can only take the constant
Constants,
outside, not
yes.
the variable.
Very good. Yes, excellent. And very well said that yes, okay, if you take x by x outside, you could have, but then and yes, even if you take x outside, you would have 1 by x here. So that 1 by x is would not be a, right? That 1 by x would not be a square because a square is a constant and 1 by x is not a constant, right? Do you understand this part as well?
Yes, I do.
So now you know that okay, not because the second type of our today's lecture is that whenever you come across this type of an integrand, you will be doing it this way, but because you can clearly see that this is a function and this is the derivative, right? Not exactly, but at least you have your variables. You have your variables. The derivative of the denominator would be, if this function is f of x, f dash x would be 3x square, right? So at least you have x square. You can bring 3 over here. That would not be an issue. You can multiply 3 and you can divide 3 here. But at least you have x square. So since you have x square, you can say that yes, I will use the second type of our today's discussion. That the integral would be this, right? So what would be our integral, our answer? This 1 by 3 would come as it is, and ln f of x. So what is f of x in my example?
3x square by
No,
x
no, 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 no,
x
no.
cube plus.
What is my f of x, Anjali? This is f of x and this is f dash of x.
X cube plus 1.
Yes. You need to be clear with these things, okay? So you had a fraction where this is the f of x, this is the derivative. Since initially you did not have the derivative in your numerator, no, but you were able to make it using some constants, right? Without using variables, you were able to make the derivative of denominator in the numerator. So yes, you can apply this directly then, right? Is it clear?
Yes.
Okay. Now I want you to solve this question. Example number 2. Integrate 6x divided by x square plus a dx. Just help me do this. Now again I know that the derivative of this is 9. The derivative of this part is 2x, right Anjani?
Yes.
So at least I have my x here. I do not have 2x, but I have x, and that x is enough. I can always make 2x in the numerator by taking 3 out. So I'll have 2x over x square plus 9 dx, and I am good to go. My form is f dash x by f of x. I can directly say that my integral is this. Do you understand?
Yes.
And why can I not use the tan inverse thing over here? Because of this x, right?
Yes.
I can always write it as x square plus 3 square. So I have x square, I have a square, and I could have taken the 6 outside, but I cannot take x outside because it is being integrated with respect to x. You can never ever take your variable outside the integral. You can never ever modify your integral according to using your variables, okay? Right. So, yeah. Now I want you to help me with this part. This is the example 3. 6 over x square plus 9 dx. Yes, now tell me how would you integrate this? What would be the derivative of x square plus 9? 2x. So can you make 2x in the numerator?
Yes, you can.
No. How can you make 2x in the numerator? You do not have any x.
Oh, no, you can't.
Do you understand this?
Yeah. Here you can take 6 outside.
Yes, you can take 6 outside. Very good. But then how would you make 2x in the numerator? You cannot make, right? So the answer is that here you cannot use the f dash x over fx thing. You cannot convert this fraction to this type because that is not possible. That involves using variables and you cannot do that, right? So how would you attempt this question? We have discussed this type as well. You can take 6 outside and you will have 1 over x
Square
square
plus 3.
3 square. Yes, now tell me. What would be the answer? We have discussed this type. If this is your a square, a is 3, 6 would come as it is, and the integral would be 1 by a, that is 1 by
1 by
3.
1 by 3
Yes,
tan
x,
inverse
yes,
of x by 3 plus c.
Very good. Okay. Do you understand this?
Yes,
100%?
yes.
Okay. Let's talk about another example then. I will give you a hint and you have to solve this. You will use this by using a bit of trigonometry as well. Now tell me.
This is sin x over cos x.
Excellent. And yes, then. Okay, wait, let me write it down. Sorry. This is you have to integrate. Okay, you can write tan x as sin x over cos x. Yes. So is it the fx over f dash x form? I mean the derivative
Yes,
of cos x is minus sign. So you need to have minus here.
yes, you need to.
So you will have minus here as well because you need to neutralize things. Okay, you need to balance things in mathematics, right?
Yes.
Did
So it
you
will
understand?
be ln,
Yeah, ln.
ln of cos x
Very good. Plus c, and this minus would come here as well, right? This minus. Do you understand this?
Yes,
Do you understand the minus part as well?
yes, I do.
Very good. Okay, we have 2 minutes. Let's see if we can do another question. Let's try doing it. X square minus x divided by 2x cube minus 3x square plus 12 dx. So how would you do this question? Again, what is your f of x? Like, think of the denominator. What is the denominator? Tell me, what is the denominator?
2x cubed minus 3x squared plus 12.
Very good. And what is the derivative of that?
6x squared minus 6x. Yeah, 6x squared minus 6x.
Okay, so the
So you can
derivative,
take 6 outside.
very good. 6 outside or inside maybe, right? I can write it down as minus 6x divided by 2x cube minus 3x square plus 12 dx. And since I have taken 6 inside, I need to have it outside as well in order to balance things, right? So the derivative of this denominator is in the numerator, agreed?
Yes,
So this would be ln 2x cube minus 3x square plus 12 plus c is the answer, right?
yes.
Okay, so we are done with this as well. Very good. Let's talk about last example, ex plus 1 divided by ex. Now think of this and tell me how would you do it, okay? Don't try to link it with the existing method we have been doing or we have discussed so far, but just use your
You
basic
have
maths.
the e of x itself.
Sorry?
E of x, integral of e of x will be e of x.
Yeah, but we have a fraction here now. So first you need to write it down like this, right?
Yes.
You can cancel these two. You will have 1 plus e to the minus x plus dx. Integration of 1 is x minus e to the minus. Okay. So for e to the minus x, you will get e to the minus x as it is. And the derivative of this power would be divided. So this is what you would get. So here the only learning part was that this itself, the fraction itself looks like a bit complicated. And whenever you come across a fraction, never ever think of it that you would be doing it by this method, okay? I mean, yes, definitely think about this as well, but understand the fact that every fraction cannot be integrated this way. As in our example, we had to the x. I agree that the derivative of e to the x is e to the x, which we have in the numerator, but we have this one as well. So this cannot be solved by this method. So I simply just simplified it by dividing ex on both. I got 1 and I got e to the minus x. So the integral of 1 is x and the integral of e to the minus x is this. Do you understand this now? E to the minus
Yes.
x dx. So I would have e to the minus x as it is divided by minus 1. Do you understand this part? The integral of e to the minus x? I'll tell you. E to the minus x dx. So the rule is that e to the minus x would come as this, just like differentiation, right? E to the minus x would come as it is, and you need to divide it by the derivative of this power. So the derivative of minus x is minus 1. So this is minus e to the
Yes.
minus x, right?
Yes.
Yeah. So we are done with the two topics we had to do today. Are you clear?
Yes. It's fine.
Yeah, I have to do another question, but we will do it in the next class. That is a bit complicated, but yes, so far we have done. I will stop the recording and then you can tell me if you have to ask something.